So suppose you are having a system like this. F is equal to mx double dot plus vx dot plus kx. So we have to convert these things into state space model. For converting these things into state space model, so this is a second order equation. So second order equation we have to convert to first order equations. So state space is that one only. So you have to convert. No need to enter it 2 o'clock. Actually that attendance module creating that time we put 2 to 4 only. Don't worry about those things. So this system f is equal to mx double dot plus vx dot plus kx. So states are the physical variables. Physical variables that is having meaning. So for a second order system, this system, you know that it having two states. One is its position, second one is its velocity. So this x and x dot are the state of the system. So in state space representation, x dot is equal to ax plus bu and y is equal to cx plus du. This is the general form of state space representation where x is the state variables, u is the input or control vector, and y is the output vector, a is the system matrix, b is the input matrix, c is output matrix, and d is feed forward matrix. So this is the general form. X dot is equal to ax plus bu, where x is the state of the system and a is the system matrix, b is the input matrix, and u is the control vector or input. This is called state space. This y is called output vector. So y is output vector. Y is equal to cx plus du, where c is the output matrix and d is the feed forward matrix. For most of the cases, d will be 0. So
Excuse
this
me,
is,
sir.
yeah,
What is that symbol? Is it y is equal to ax plus bu?
x dot. This
Okay, okay,
x dot.
okay.
So nth order differential equation, nth order differential equation, we are converting to n first order differential equation, and we are forming a matrix vector form. Matrix vector form. So for the system, f is equal to mx double dot plus bx dot plus kx. We choose x1 as on state, that is equal to x, x1 is equal to x, that is this x is taken as on state, and the derivative of this x1 dot is equal to, that will be equal to x dot, that is taken as second state, that is x2. So x1 we are taking as x, and x1 dot is equal to x2, and this x2 dot is equal to x double dot, that is here. So these are the two states, x1 and x2. This is x1 dot only, x1 dot is equal to x dot, that is taken as x2. So you can write this function. So f is equal to mx2 dot plus bx2 plus kx1. So where the unknown quantity is x2 dot, so we keep it as yesterday what we have done, f by m plus minus b by m x2 minus k by m x1. So x2 dot you are able to get this form. So now we have to convert this to a matrix vector form. So here x1 dot, we know that it is x2, and x2 dot equal to this one, this equation. So we can convert this one into x1 dot x2 dot, that is equal to, so x1 dot is equal to x2 only. So this system matrix is coming like this, and then x1 x2, that is a x plus b into u. This is a linear system having only one input, so u will be one only one input is there. So I have to fill the x1 dot is equal to x2. x2 means here 0 and here 1. This is x2 plus b into u. For x1 dot there is no input, so b is 0, and u is, that is this f is the input. So f, you have to write it. And x2 dot is equal to minus k by m x1 minus b by m x2. So minus k by m minus b by m x2, and this f is multiplied by 1 by m. So this b matrix is 1 by m. So this is the state vector formation. x1 dot x2 dot is equal to 0 1 minus k by m minus b by m into x1 x2 plus 0 1 by m into f. So x dot is equal to ax plus bu. Now we have to write the output equation, y is equal to cx plus du, where c is the output matrix and y is the output vector. So y is equal to 1 0 into x1 x2, and d is 0. So this is the state space representation of the system. This system, state space representation of the system is like this. So now we can try in MATLAB. So m is 10, b is 5, and k is 6. So I have to define a, b, c, d vectors. So A is equal to 0, 1 minus k by m minus b by m, and b is 0, 1 by m, c is 1, 0, and d is 0. So I have to enter these things in MATLAB. So capital A is equal to 0, 1 minus k by m minus b by m, a equal to 0, 1 minus k by m b by m, and b equal to 0, 1 by m, that is a column 0, 1 by m, C matrix is 1, 0, and D is 0. So I entered these values, A, B, C, D values I entered there. Now my system is equal to state space of A comma B comma C comma D. So this will create a state space model. That system state space model I will get it here. So you run it, you will get ABCD matrices and you will get the system. So this is in the state space model. So if you want to convert this state space model into transfer function, state space model into transfer function, you will get the numerator comma denominator values. So that things you have to enter like this. Numerator denominator is equal to SS to TF. This is the command for converting the state space to transfer function. A comma B comma C comma D. So you will get the numerator and denominator. So if you want this transfer function SYSO1 equal to TF of num comma det. So you will get for the system m is equal to 10, b is equal to 5, k is equal to 6. Same thing as you are getting earlier like this. So this is how we are converting the system into transfer function into state space, and both are equal. So you can try this one. So you can, if you understand this one, then you can easily do the things. And the command using is yes, for state space it is system is equal to ss of a comma b comma c comma d. For converting this one to Laplace domain or converting that to transfer function model, num comma n is equal to ss to tf a comma b comma c comma d. So system 1 you will get tf of n numerator comma denominator, this transfer function you will get. Now you can convert this transfer function into state space model also. The command is tf to ss only. tf to ss. You can try these things now. After completing, you just put it in chat message. Any doubt is there, you can ask.
So, excuse me.
Yeah.
When you define system state.
Yeah,
Uh, is that order like it's sensitive to that order A B C D?
yeah. This matrix, this is actually x dot is equal to ax plus bu.
O- Okay,
So
so
this A matrix is actually my system matrix, and B is input matrix, and
yes, sir.
C is output matrix, and D is feed forward. So you can change this name, but here it is taking here this ABCD first system matrix input output matrix feed forward. Like that only you have to do.
Okay, sir. Thank you, sir.
What is D, sir?
D is feed forward. This these linear systems, and this you are studied this Mason gain formula like that things now. There you are having these nodes will be there, and from this node something going directly here, that is called feed forward. This one, both direction will be same. This is called feed forward. You are studied signal flow graph now.
Yes, sir. I got it.
Yeah, there these are the nodes definition, all the things you know now.
Yes, sir.
What do you mean by input node?
Sir, the one which has only one outgoing branch.
Input node, yeah, okay. What do you mean by non-touching loops?
Sir, when two loops do not have any node in common.
So what do you mean by a loop?
Sir, a loop.
A path that starts and ends at the same node without repeating any node.
So this one is a loop right now.
Yes, sir.
Yes, sir.
So this one is a loop.
Yes, sir.
Yes, sir.
So it is touching other nodes also. Na?
So, what are you asking?
So somebody told that without touching other nodes.
Without repeating a node, I said.
Yeah, okay.
And touch only once.
Yeah, okay. Right. So you know how to make this loop gain at all. How to take the transformation of these systems. So
Yes,
you
sir.
can try that yesterday what we are done using this one. That is 1 by m plus minus 2 integrators and this one from here to here on here to here. These two are minus. And this is p by m and that is k by m. K by m. This is x and this is f. So you can try these things. You will get that same transformation. So second order system time response analysis is start.
Not yet.
So, next week we will start the lab that motor control and other things. What you have learned in last class. So you just prepare those things and come. So your lab is actually once in a week only. So first batch can come Thursday and other can come in Friday.
Sir, till what roll number are you deciding on the first and second batch?
That's up to your class representative. Total 65, I think.
It's 65.
Yes, sir.
So one batch will be 33, another will be 32.
So we can decide and send the list, sir.
Yeah, you can
Okay.
send me the list.
Okay, sir.
So up to today's lab, you need not submit any reports. So next week onwards, you will start the lab. After that, you have to submit reports. Anything else?
Sir, like in Python, sir, is there any concept of dictionary in MATLAB?
No. You can define anything, and you can dictionary like things are not there, but you can have some. In Simulink, there are lot of things they are merged and they just like dictionary only it is shown. Only one block for that purpose. Hey, you are studying Python also.
Yes, sir.
That
No,
is
no, sir.
No, sir.
Sir,
It's
sir, not
just
sir,
we are not taught Python.
not
He is
all.
just
Only that 1%.
yeah, you study those things. That is very good. After coming here, you can do a lot of projects in Raspberry or something like that. Actually, Python is much simpler than this C
C,
and
C.
I think few of you people are attended that Python course we are conducted in your first year. I think Nirbhay Tyagi is there.
Yes, sir.
Yeah, you attended that course now.
No, sir.
Srinidhi is attended, I think.
In the first year.
Yeah, first year. So you completed these things?
Yes, sir.
Yes,
yes, sir.
Yeah, okay. So now we can move to the TID controller. So the control system needs the system output to be controlled. So we need a sensor to measure the output, and there will be a comparator. So desired input, and here the controller is coming. So there are so many controllers, but in your lab course only you are studying proportional controller. That is simply a gain block, just like adding a gain. Second one is PI controller. So we can add this as a gain block, proportional controller. proportional plus integral, that is PI controller, P plus I controller, proportional plus integral controller. So the structure will be, we are having a Kp gain, proportional gain, and from this signal we are having a Ki gain and one integrate, and these two things are added together to get the control output. So here is the error signal. So this plus and minus, here it will come the error signal. So error signal is going to the controller. So this error signal and this Kp is the proportional controller, and this one is integrated controller. So these two are added up and the control output is produced. This kind of system is called P plus I, proportional plus integral controller. And third type of controller is P plus I plus rate feedback. So there is a feedback loop. So you are having a proportional Kp and the Ki into 1 by S. These two are added up. Here is the error signal will come. And you will measure some rate, means that velocity. So motor or something like that, you will measure the rate, and that rate gain you will put it, and this is actually feedback only. This kind of controller is called P plus I plus rate feedback. And the third one is PID, P plus I plus derivative. So the structure will be simple: Kp K into 1 by S and Kd into S. So one is integrator, and another one is differentiator, plus plus, and this one also plus. So in MATLAB, if you are implementing just this S alone, it will create error because it is a improper transfer function. So improper transfer function. So what do you mean by proper transfer function?
Degree
So
of
degree of
denominator will be greater.
Yeah, that is the proper transfer function. So you have to make this transfer function also proper. So you will add a pole at the very far. So it will be, you will simply add a pole at the very far. So the far means you can add, if the system poles are like this, you can add a pole at this minimum 10 times this pole. Minimum value you can add maximum anywhere. It won't affect these dominant poles. So like this only you are implementing in this MATLAB S plus infinity like that. So this P will be tending to infinity. So this is a proper transfer function. So like that only you are doing it in MATLAB. Otherwise it will create some error. Nowadays MATLAB corrected those errors. If you are designing these things, it will directly add a pole. That is MATLAB choice only, but you are, if MATLAB is adding somewhere here. If suppose MATLAB is adding here, it may affect these folds. So minimum 10 times you have to do. So you have to do by yourself. MATLAB is doing that, will create its own logic and it will do it. So be careful about these things, otherwise your answer will be something different. If you are designing something MATLAB is adding means it can add anywhere. So these are the controllers. Control design and other things you will study in the control system course. How you are designing a controller using any techniques like root locus if you are doing in time domain, or body analysis if you are doing in frequency domain. Those things that will cover in your lab, in your theory class. So we are giving you the controller parameters and how to simulate and what are the inference you are getting. Those things you have to fill. That is how the lab is going on. So any doubts regarding last that SAMs are taken those that motor control system, motor modeling and other things. So nobody having any doubts regarding those you are completed earlier.
Sir, this improper transfer function alone, can you show an example in Simulink?
Simulink, you just take a trans function and things. This result you will get.
Okay, sir. So next, how to rectify it?
That matter won't create nowadays like these functions. Like these functions, MATLAB won't create. So if it is like this, it will. If it is like this, numerator and denominator polynomials are equal, it will create. If the numerator degrees coefficient is slightly greater than denominator, it will show this error. That is the case for this one also. If you are having a differentiator only means 1 0, and this is not there. This is a differentiator, so it will create this error. So you have to set a value here. It will act as a differentiator. So if you are giving a step signal to a differentiator, what will happen?
Ramp, sorry,
Impulse.
What will happen? You can just see in the scope if you don't know. This one only you will get it. So here you are increasing this 100, this point will be shifting somewhat here. That will be a proper differentiator. So you can try these things. Any other doubts? There one more thing is there. That is algebraic loop. So algebraic loop. So algebraic loop is something like this. Plus minus and this 2. This loop is called algebraic loop. If something like this is coming in MATLAB, it will create the algebraic loop error. So what is the issue with this? You can try this one also. It will create a algebraic loop error.
sir, because it is divided by 1 minus 0, so it is not defined.
0.
So this can be this feedback can be like g upon 1 plus gh. So when we do that, it will become 2 upon 1 minus 2, which is negative. So it will give a negative gain.
It's 1 plus 2. Denominator is
1
5.
plus 2.
Minus. It's a negative feedback. Minus. So g by 1 plus 2 by 1 plus 2 into 5.
Actually, you try this one in MATLAB and in Simulink. It will create a algebraic loop error. And you have to tell what is the algebraic loop error. But MATLAB will give some basic things. From that you have to interpret those things. You need not go for this transfer function and other things. This is one gain and this one is another gain. Simply make a loop. And this input and output. Then you run it. You're done?
Sir, it is working.
Two gains you are added.
Yes, sir.
Working.
Gain of 2 in the forward path and gain of 5 in the feedback.
Sir, I think you are muted.
So this, so while you are running this one, it will show on warning. That is algebraic loop, something like this.
Yes, sir.
So earlier MATLAB will not run for this kind of systems. It will create one error because this is this loop or this system having no dynamics. When you are giving here, it will be 2 here, 5 here. So it don't having any delay or something like that. So it will be treating as a algebraic loop and MATLAB will not run. So nowadays they done with something called delaying this process. So in algebraic loop or something is there, they will MATLAB will itself create one small delay in this line. So that is why this earlier that error will come. Now that error is they are diluted it to a warning. So this kind of system we cannot use. because it will create some problems. For that purpose, you will add some filter in between. Some, if the algebraic to be something is coming, you will add a filter, and that filter will create a delay element, and that will work. So if you have completed these things and if you don't have any doubts, we can meet next week with the first labs exercise. Okay.
Okay, sir.
So
Yes, sir.
one minute.
Yeah. Okay.
Is the prerequisites for next lab will be only to revise the things that we were taught by sir.
Yeah, that um, we'll give the lab sheets earlier, and I will explain how it is doing.
Okay, okay, sir.
So if you are having any doubts regarding earlier lab sessions or class or something, you can just ask me.
Okay, sir. Thank you, sir.
Okay.
Thank you, sir.
Okay.
Thank
Thank
you,
you,
sir.
sir.
Thank you,
Thank
sir.
you, sir.